So I wanted to just say a few things before we have Randall come up, kind of introduce you guys to what we're doing. You know, when we say the war for wisdom, it's kind of an open phrase. A lot of people can interpret that a lot of different ways. Usually when you look up a dictionary definition of wisdom, it says you can make good decisions, you know, you got good judgment, it comes from having experience. But our war for wisdom goes far beyond these definitions. Today is about the war for our minds. If we allow our thoughts to be controlled by the opinions of others, then we'll be made sheep. But if we learn to think for ourselves, we will grow strong and wise. If our education system is working so well, why are only 40% of students reading at a basic level? Why are 54% of adults in the United States reading at a 6th grade level? Why are students coming out of university with a bunch of debt and a very hollow degree? These are questions that need to be answered. The philosophies of tomorrow are born in the youth of today. For this reason, we must be educating our children effectively. What we are doing is not working, but today we're joined by a man who has a plan to fix that. And that man, if you put your hands together, is Randall Carlson.
You're good. Thanks, everybody. It's great to be here and see such all these good-looking faces. So we're sitting in a Masonic lodge right now. You're aware of that, right? So now this is a question for non-Masons. I know there's some Masons mixed around here. This is one of the things that I'm always kind of hammering on. I will call up clients and things, and you know, I have a design build company. So somebody's talking to me on the phone, and I'm trying to get a picture of what they want, and I say, okay, well, which way does your house face? Like when you walk out the front door. Oh, I don't know. Okay, well, just sit tight. I'll be there as quick as I possibly can. So we're sitting in a Masonic lodge right now, and you are facing what direction? Who said that? Okay, I said now no Masons, because Masons, if you were a Mason, they didn't know that. Yes, facing north. All Masonic lodges are laid out east to west. Ed was pointing out the importance of east-west, you know, because east-west is the direction of the equinoxes. Now, Ed, in his lambda, is one of the most interesting things that I think he does in that lambda diagram with the doubling and the tripling of the numbers, because that leads us into the whole canon of cosmic numerology, if you will. And some of the numbers that show up recurrently, redundantly, over and over again are found all over the ancient world, utilized in architecture and art, even in sacred literature. I'll give you an example. Ed was talking about the number 432. Now, 432 is found in numerous places. You find it, it's the basis of the Vedic Yuga cycles, right? You've got the Kali Yuga, which is 432,000 years, and then you've got the Maha Yuga, which is the grand cycle encompassing the Kali, the Dwapara, the Treta, and the Satya Yuga, the 4 yugas, which are all built on a system that we get from Hebrew Kabbalah called the Tetragrammaton, which is 1, 2, 3, 4. So you've got the unit 1 is your basic unit, which is 432,000 years, and then you got your Dwapara, which is twice that, or 864,000, and then you've got your Treta, which is 1,296,000, and finally you've got your Satya, which is 1,728,000. And then you add all those together and you get 4,320,000, or 10 times the starting number, okay? So, and then if we go to the Sumerian king lists, we find that the sum of all of the 10 antediluvian kings, the pre-flood kings, all of the reigns incorporate these sacred numbers, and the totality of these reigns is 432,000 years. So it's like the Sumerian king lists lead us up to that number 142,000 as being the cycle of the antediluvian kings, and then we get into the Vedic tradition, and that picks up the number 432,000 and carries it up by an order of magnitude up to 4,320,000. Now, we know, everybody knows there are 24 hours in a day. Of those 24 hours, each hour is 60 minutes. So how many minutes is there in a day? Well, it's going to be 60 times 24, which will be 1,440. Now, you might know from the Bible that the number 144 appears several times. For example, there are 144,000 redeemed of the earth, which is an interesting concept. And what does that mean? We won't have an opportunity to get into that today. But then also there is the wall around the holy city, the New Jerusalem, which is 144 cubits. So the New Jerusalem vision, which appears to St. John the Divine in the book of Revelations, and he describes the New Jerusalem lying four square, and the length, the height, and the breadth of it are equal. Well, if something's lying four square and it's got length, height, and breadth, it's probably a cube. So he describes this vision of the holy city descending out of heaven from God as a cube, and he says it lieth 12,000 furlongs on a side. So right there, it's introducing a geometric analogy, which, if you dive into it, is interesting because it's sort of a portal that leads you right into this whole, literally the structure of reality and the structure of the solar system and our world in which we inhabit. Somebody, way back whenever, prehistory, I believe, it had to have been prehistory, decided that the cycle of the day, the diurnal cycle as it's called, which is the rotation of the earth on its axis with respect to the sun. Now, to get it very precise, do you know what the local meridian is? The local meridian is, if you're facing due south, which I'm doing right now, at due south, you draw a line up through the zenith. What's the zenith? The zenith is the point that if you were holding a plumb bob in your hand, the plumb bob would be pointing towards the center of the Earth's mass. The other side would be pointing to the sky at the zenith. You could think of this, if you had a completely and perfectly flat plane, like maybe if you're at a very calm sea, the zenith would be 90 degrees in every direction down to the horizon, right? So now you draw a line from the zenith due south, and that's your local meridian. Now picture the orb of the sun with a point, a very, very small point right at the center. Now, you have something that could represent your local meridian. Now, what this could be is, like I just set up a framework and I drop a plumb bob from it. And I have a position here, and I get this several ways that I can geometrically lay out a east-west, very accurate east-west and north-south axis, right? So I drop a plumb bob, and that line can represent the local meridian. And if I'm making observations, and we're not necessarily looking at this directly, but I'm imagining this is a visual exercise. If you imagine the sun with a dot right at the center, that little dot crosses the local meridian. And now you have a stopwatch, and you time it. How long does it take for the sun to come back around and for that dot to line up with the local meridian? And that's precisely your 24 hours, your tropical day. Now the 24 hours is 60 minutes, and 60 minutes times 24 is 1,440. How many seconds? How many seconds in a day? Anybody know that number? There's 86,400 seconds. Now, if you tack a zero onto that, it gives you the Dwapara Yuga in years, right? It's interesting that those numbers are related simply by a power of 10. But 86,000, now let's think about it. You've got 86,400 seconds in one diurnal rotation of the Earth's on its axis. So we all know what equinox is, I hope. Equinox is a moment when the day and the night are equal. Now, how long is that? Well, we usually think of, oh, today is equinox, right? And you say, well, whatever it is, March 21st, 22nd, or September 21st, 22nd, it's equinox. But equinox is not a day. It's not an hour, it's not a minute, it's not a second. It's an indefinably small point, right? Because you're talking about constant motion, and I don't know how many of you have studied calculus, but if you have, you know what the limit is. You know that the limit is the thing you're going to, but you never really even get there. And at some point, you got to round it off and you say, okay, I don't need this to 100 millionth of a second accuracy to solve the problem, whatever the problem is. I just need it. In my case, I use 1 second or a half a second. I use a half a second. There's a reason for that. But so what you do is you define that moment of equinox, vernal or autumnal equinox, right? At that moment, you have perfect balance. Day and night, light and dark, are of equal duration. Half of 86,400 is 43,200. So there's Ed's number, 432, right there, see? So how did those numbers get in there? Well, I've looked and looked and looked. I haven't been able to find out who decided originally to define the day as 24 hours, 1,440 minutes, 86,400 seconds. I have no idea. But those numbers recur over and over again, even in the way that we measure our own scaling of time and space. So another number that Ed brought up was 25,920, the great year, as it's been called in ancient times by ancient peoples. Another great year is I think of that as the Earth's third motion. Diurnal motion on its axis, revolutionary motion about the sun, and then the precessional motion, which is the axis of the Earth spinning around like a top in the opposite direction that almost all other celestial motion is seen to go, from west towards the east. Whereas precessional motion, what we see is if we're looking to the sky regularly and we see the solstices points, or at right angles to that, the equinoctial points, they're moving. I'll show you some graphs in a minute. They're moving at this rate of 50 arc seconds per year, right? 50 arc seconds per year, which is not very much. Now, how would you visualize 50 arc seconds per year if you're out looking at the sky? Well, 50 arc seconds, if it's 60 seconds, that's a minute of arc, right? So think of it this way. If you're looking at the full moon or the orb of the sun, both of them displace about a half a degree. And if you all have seen total solar eclipses, you know this truly remarkable phenomena where the disk of the moon is exactly juxtaposed over the orb of the sun. And of course, the reason for that is because the sun is 400 times larger than the moon, and it's also 400 times farther away than the moon, give or take a little bit in there, which is kind of a remarkable coincidence when you think about it, and it leads us into down some other rabbit holes. But there are a number of things like this that are pretty remarkable. So you've got this 400-to-1 relationship, and of course, the astronomers and astrophysicists are telling us that the moon is steadily moving away from the Earth, right? So this 400-to-1 relationship is something that's pretty much exclusive to our own times. It's not something that's going to disappear in a century or two, but over a period of millennia and then tens of millennia, that will slowly shift away. And pretty soon as the moon moves farther away, we won't get total solar eclipses anymore. So total solar eclipses are kind of something that's unique and special for our own epoch, this time that we humans have kind of arisen from wherever we came from on this planet. But the point is that when you begin to look at the ancient traditions, and we can look at numerological traditions, we can look at architectural traditions, we can look at symbolical traditions, we can look at art. I mentioned sacred literature. Here's something that's not too widely known, but some of you I'm sure are aware of that, is that some of the ancient languages, the traditional sacred languages, particularly in the Semitic lands, Hebrew and Greek are two examples, but it's also true for Sanskrit. It's also true to a certain extent to some of the Arabic alphabets, but it really shows up prominently in both the Hebrew and the Greek, and that's this. Before the advent of the Hindu-Arabic numeral system, which basically came up with a system of numbers different from the system of symbols that were used as letters. Prior to that, the same symbol served a dual function, both letters and numerical values. What this means is something very interesting, which is you can go into the Hebrew scriptures, or you can go into some of the Greek sacred writings. Even Plato, I think, was aware of this system. And you can take words, phrases, names, and you can substitute in the numerical values, and what you end up is the same suite of cosmological numbers. So in other words, and I'm not going to get into that today, I'm just putting this out there so that you're aware of it if you're not already, that if you peel back the outer layers of the sacred writings, which are literary and metaphorical and symbolical, underlying there is a whole system of cosmic mathematics. And it's been there for, hundreds, if not thousands of years, and people have not really even been aware of it. Now, you can find numerous examples of the embedding of sacred numbers in everyday things. And what this tells us, in a way, to my mind, is that a lot of the everyday things are actually very sacred. And it's just training yourself to be able to perceive what's hidden in the world around us, because that's very much what it's about. One of my quotes here, let's see, I think I've got it right here handy. Let me pull this up. I've been known to say things out of turn on several occasions, and with consequence. What?
Expletives?
Well, no, that would be minor and insignificant compared to some of the things. No, some of you know that I recently did a Joe Rogan podcast that has not seen the light of day. And there's a long story behind that, but maybe we can get into that a little bit. Anyways, there's an alchemical saying, and it goes like this. It is the glory of God to hide things, and it is the glory of man to find them. So that's what we're doing. We're looking for those things that are hidden in the world, everywhere around us. Okay, so I'll give you an example. How many of you ever been to a horse race? Stephen, I knew you had. Okay, the horse racing track. What is the unit of measure used for that? Now, Stephen, you're disappointing me. What is it? A furlong. A furlong, yes. Now, a furlong, we find a reference to that in the book of Revelations. The city lieth foursquare, the length, the height, and the breadth of it are equal, 12,000 furlongs. So how long is a furlong? Who knows? Anybody know how long a furlong? Now, not so long ago, most people probably would have known that, but unless you're an aficionado of horse racing, you probably wouldn't know. A furlong is 660 feet, 1/8 of a mile. Who's good with a calculator? Good. Can I hand you this and you be my helper here today? Okay. What's your name?
Glenn.
Glenn. Okay. Glenn, I just told you that a furlong is 1/8 of a mile and it's 660 feet. So how many inches are there, Glenn, in a furlong if it's 660 feet?
7,920.
7,920 inches in a furlong. Anybody want to take a guess at how many miles there are in the diameter of the Earth at the tropics? 7,920 miles. There is, as Ed mentioned here, you've got two ratios here. You've got the ratio of the Earth to a mile, and you've got the ratio of a furlong to an inch. Now, the mathematical definition of proportion is that whenever you have two ratios that are equal, you now have a proportion. Now, in some of my classes and my students, I've taken my students out like to a big open parking lot with my 150-foot fiberglass measuring tape, and we've laid out a furlong, right, marked it in chalk, 660 feet away, more than 2 football fields. I'll have somebody stand at one end, at both ends, right, and then we'll take our thumb. This is the derivation of the inch, right? And I'll say, put your thumb there and we'll mark that in chalk. And now that inch to that furlong is exactly the ratio of a mile to the size of the Earth. Now, mile, the word itself comes from the Latin, which means what? Means what? 1,000. So what's the connection between the mile and 1,000? 1,000 what? Paces. So if you go out and you mark off 1,000 paces, this is how a lot of times a mile was estimated in the old days. Now, different cultures had different miles, but it was very common to step off 1,000 paces. Now, you didn't take every step. That was too many. You counted like every time your right foot hit the ground, and you would count that off. You count 1,000 of those, How many feet in a mile? Good. Chris, if you didn't know that, I would be very, very disappointed in you. Because Chris has been on 3 tours now. So you're expected by tour number 3 to know how many feet are in a mile. Because I'll say, Chris, I need a photograph here for scale. Would you please run 1 mile south? 5,280 feet. So that's 1,000 paces. So if you have 5,280 feet and you go 1,000 paces, then what's the average length of each one of those paces? 5.28 feet. Now, here's an interesting statistic. If we were to recreate and duplicate Stonehenge, which I've actually built both models, computer models and 3D models that I've done to reconstruct Stonehenge using multiple surveys, all of which are pretty close, within a few inches. And a few inches fudge factor is okay. It doesn't change the overall geometric dynamic, okay? If you go from the center point of the Stonehenge out to the outer face of the so-called Sarsen stone circle, which is the big stones of red sandstone, they measure right at 52.8 feet. Right at 52.8 feet. Which means 52.8 feet is 1/100th of a mile. Does that suggest the possibility that the builders of Stonehenge were using some unit of measurement that is somehow related and connected to our modern day imperial mile, is it called? Now, Glenn, you've got 5.28 feet. Don't go that times 2. 5.28 feet times 2. And tell me what you get. 10.56. 10.56. Now, if you take the reconstructions of Stonehenge and you've got a ring of uprights, estimated to be 30 uprights, and you got the lintels, the average distance, published distance, separating each of those, the length of the lintels in the center of each of the Sarsen stone uprights is 10.56 feet. Now, what's that times 30? Is it 316.8 feet? Yeah. So now, let's talk about the Holy Grail for a minute. The Holy Grail is a very powerful symbol of the Western mystery tradition. In fact, it's one of the most powerful symbols in the whole esoteric tradition of the world, right? The Grail, any of you ever read any of the Grail romances, Wolfram von Eschenbach, Chrétien de Troyes, Robert de Boron? How many of you seen Monty Python and the Holy Grail? So it turns out that that's what a lot of people actually know about the Holy Grail. But how many of you ever seen the movie Excalibur, the John Borman film? Now that's based on Thomas Mallory's version of the Grail stories. Okay, very, very intricate, involved, very, very mysterious. Almost when you read, if you ever do this, and I recommend it to anybody who's really interested in Western mysticism or Western esotericism, to just take a few months sometime and immerse yourself in those Grail stories. And there's plenty of good translations out there, but what you'll kind of take away from it is there's a very dreamlike quality to them, in that, you know how in a dream you'll be in one environment and it'll kind of mysteriously morph into another environment, or a character will enter your dream as one person or entity, and then they morph into somebody else. That's very much like what these Grail stories are like. In some of them, you've got a character who's King Arthur. In another story, it's basically the same characters with the same events and things associated, but it's Bran. Or in another one, it's the Fisher King. Or in another one, it's Anfortas. But overall, the idea behind it is very similar, is that there's this quest for something which has been lost. And when that, whatever it was, got lost, there were consequences. The quality of life on Earth declined. The land around about, like in most of the stories, have either come out of France or England. A lot of them came out of Germany. There were others came out of the Netherlands, but the most well-known ones were French, with some of the lesser well-knowns in English. But you know that the English traditions are very much associated with the Grail because, you know, part of the quest of the Arthurian Knights was to find the Grail. And King Arthur was debilitated. Now, in the different stories, the debilitation may be a sickness, it may be a wound. It may be different types of wound, but whatever the case is, the character who is suffering from this is not healing. Meanwhile, round about, the landscape is laid waste. The crops are dying in the field. There's famine, there's pestilence. The cure for both the ailing king and the ailing landscape is the same, and it's symbolized by the Grail. Now, we know that the Grail stories precede Christianity. They go back to the Celts for sure. But we find parallels in many, many traditions around the world. There was the Cauldron of Lugh, right? But the Grail stories became Christianized after the 1st and 2nd century, and by the time, I think it was Chrétien de Troyes who first recast around maybe the 3rd quarter of the 12th century. He recast the stories within a Christian framework. And in this version, there was the Last Supper that preceded the crucifixion. And as the story goes, Jesus gave a couple of the unnamed disciples a task that they had to go into Jerusalem, and they would encounter a man carrying a water pitcher. And they were supposed to say certain things to him, almost as if it was passwords, and then he would lead them to a secret place where they could all meet to have the Last Supper together. Then during the Last Supper, they passed around this cup, and they all drank from the cup. And the next day, Jesus is crucified. According to the details that you can pull together from the Synoptic Gospels, is that he was on the cross for only 6 hours. Crucifixion was designed to be a very prolonged and agonizing death that took days. So Joseph of Arimathea, who was the host of the Last Supper, and probably the one who owned the house in which they met, he goes to Pilate and asks Pilate for the body, and Pilate doesn't believe that he's actually dead, so he sends out a centurion. The centurion has the famous lance, pierces him in the side, blood and water flow forth. Centurion comes back and says, yeah, I prodded him with the lance and there was no response, so he's dead. Pilate says, okay, you can go ahead and take the body. He takes the body down. But as he does so, he collects some of the fluids flowing from his side in the cup, which is then sealed up. So the cup becomes what's called a ciborium, which is a sealed cup. Now he goes through adventures, he's imprisoned and so forth, and there's some miraculous things, the way he gets out and how he's fed. But to pick up the thread of the story, he journeys to England with 12 followers, 12 disciples. He presents himself to Arviragus, a pagan chieftain. And Arviragus believes in his mission and says, I'm going to endow you with 12 hides of land. 12 hides, which was an ancient British system of land measurement. I'm going to give you 12 hides of land, and you can build, this will be your sacred precinct. And at the center of this, you can build a chapel. So then Joseph of Arimathea builds a small chapel whose dimensions have come down to us. And the reason is because whenever this chapel, which turned out to be just a little under 40 feet in diameter, would fall into ruin, descendants of the original disciples of Joseph of Arimathea would reconstruct it, being very, very careful to preserve the original dimensions. So it went through a series of iterations up until about the 10th century. Then an abbey was built. The original dimensions were incorporated into the abbey. That abbey burned down, and they built another abbey in the 12th century. And on the western end of it, they built a little chapel dedicated to Saint Mary. Now, Mary, the Mary, mother of Jesus, or Mary Magdalene, we don't know for sure, but it was dedicated to to Mary. The width of that chapel preserved the original diameter of the circular chapel. Now, which was refined at 39.6 feet. Now, that's interesting. Then the length of it was a special multiplication of this 39.6 feet. It was multiplied by the square root of 3. I'm going to show you what that means in a minute when we get to the slides. Square root of 3 was one of the sacred numbers that was used throughout art and architecture and so on. It works out to be about, in round numbers, 1.732. So in other words, if you start out with a rectangle whose short side is 1, then its rectangle is in that ratio, its long side is going to be that times the square root of 3, which I said would be about 1.732. Or in other words, think of it this way. If you had a rectangle that was based with those ratios, it was 10 feet on the short side, it would be 17.32 feet on the long side, right? So you had this special rectangle that perfectly defines the dimensions of St. Mary's Chapel. Okay, now that sat at the center of the sacred precinct that was 12 hides of land. A hide of land was 120 of our modern acres. But I say modern acres because I'm going to imply here that when we talk about land measure in acres, we're not talking about something modern. We're talking about something very, very ancient. So a hide's 120 acres. So what's 12 times 120, Glenn? Is it 1,440 acres? So that's the same number of acres in the sacred precinct as there are minutes in one diurnal axis. So now look, think about this, because this is the thing that I want you to really become aware of. We're talking in one case about a measure of time, in another case about a measure of space, right? And we find this recurring over and over again, that the same canon of numbers was used both to measure time and space. So the sacred temples were built using these numbers. Now here's something interesting. I don't know if Ed mentioned this or not, but think about the word temple, right? And then think about the word, let's say, temporal. Temple is a physical manifestation of a sacred building. Temporal refers to the passage of time. Think of the word tempo, right? These words are related. Why? Because the sacred spatial relationships manifested the same numbers as the sacred temporal relationships. Okay, so it gets pretty involved, but once you begin to get a handle on these numbers and how they connect geometrically, it begins to all fall in place. Now let's see if you can do this, Glenn. This is going to be, and let me see if I can guide you through this. Okay, we got 1,440 acres, okay? Now, how many, I bet you there's nobody in here who knows this. How many square feet in a square acre?
54,280.
How many?
54,280.
No. Well, how many acres, how many square acres in a mile? How many acres in a square mile? Do this, Glenn. We've determined that a mile is 5,280 feet, right? So now, put that number, do you see the little x squared button there? Go 5,280, square that number. That's the number of square feet in a square mile.
27,878,400.
Okay, that number is not so important to know right now because that's the number that's leading us to where we're going. That's a square mile. There's 640 acres in a square mile, so divide that number by 640.
43,560.
43,560 square feet in an acre. Now, we just determined that there were 1,440 acres in the sacred precinct, which is usually described as lying 4 square, okay? So you got 43,560. Now go times 1,440. You get a big number.
62,726,400.
Now I'm sure everybody here knew that, right? Okay, so now what we've just done is how many square feet in the sacred precinct. So now if we visualize this as lying four square, we picture this square and it was, what was the number? Yeah.
62,726,000.
Okay, so now that's the total square. Now, who can grasp what that would look like, right? Well, what we have to do is now figure out what would be a square. How many feet would be on the side of a square that had that many square feet? So all you got is one button away from it, push the square root button and tell me what you get.
7920.
Did you get it? So in other words, the sacred precinct is laid out on the earth number. We had to go through all of this convoluted mathematics to get to it, but then we see that that square, that sacred precinct that lieth four square, is 7,920 feet on a side. So now we have another ratio, and we have in our proportional relationships. So as an inch is to a furlong, a foot is to the side of the sacred precinct at Glastonbury, as a mile is to the earth. Is this a coincidence? Or is there something going on here? Is there intent here? When somebody decides, well, obviously, what's the traditional explanation for, well, an inch, the width of the thumb, right? A foot, the length of your foot. Well, and see, okay, what about a cubit? What's a cubit? Elbow to fingertip, right? Latin was cubitus, I believe, which meant your elbow, but elbow to fingertip, right? And we talked about the pace being when you're walking over the earth. Now, here's the thing. All of these units of measurement are standardizations of the human geometry. Because what this is leading us to is an interesting insight, that we humans are created in the image of God. And ultimately, this canon of sacred numbers, that's the origin of it. And we can begin to see that these canon of sacred numbers prevails throughout all of creation. We can begin to look, for example, the orbit of Jupiter in days with a very slight tweaking is 4,320 days in its trip around the sun. Coincidence? No. In fact, when you really get into it and you begin to dissect these metaphors, these geometric metaphors that have come down to us through these various means, what we see is that, well, the Holy City is nothing less than a model of the entire solar system. And what we now know about the solar system is that the arrangement of the sun, the size of the sun, the radiant output of the sun, the distance of the earth, the size and mass of the earth, the distance from the sun, the fact that there's a moon around the earth, right? And the moon has a very profound effect on everything that happens on earth. We look at the planets all the way out to the outer planets, and it's all a vast work of architecture whose parameters are very narrowly defined. If you change those parameters even in the slightest, all of this goes away. Now, how many other worlds out there are there in the galaxy, in the universe, that manifest these very precise parameters? I don't know. But certainly this one, this world that we inhabit does. And when we talk about the world, we're not just talking about the planet. Because how did life get here? Well, some of the theories are that it was delivered by comets, right? How did the water get here? The hydrocarbons. Well, some of the very prevailing theories that I think in the end are going to end up being verified are that the water, the hydrocarbons, even the precursors to life itself were delivered to the earth via comets. Well, here's an interesting thing. As we begin to understand the architecture of the solar system now, we go outside the orbit of Neptune. You know, you go Jupiter, Saturn, Uranus, Neptune. We go outside the orbit of Neptune, and we get into the zone of comets, which is the primordial material out of which the rest of the solar, left over after the creation of the rest of the solar system. I think of it kind of as the material that the builders rejected, to use the biblical metaphor, right? You've got the Kuiper disk, as it's called, because it was first hypothesized by Gerard Kuiper. Outside of that, it phases into the Oort cloud, a vast spherical shell of billions of comets, right? Picture a vast shell of these comets, and then it grades into this Kuiper disk, which pretty much lies in the same plane, which is the orbital plane of the planets, which is what we call the plane of the ecliptic. Well, it turns out that, now this group of engineers and mathematicians did this probably 10, 15 years ago. They worked out the mathematics of the quasi-stable comets within the inner zone of the Kuiper disk, and this is what they discovered was that, quasi-stable means that as opposed to very stable, like imagine you've got a hill and a valley, and you've got a round ball, and you place it in the valley. Well, it's not going to go anywhere unless it's subject to a very powerful dominant force, a motive force. But take the same ball and put it on top of the hill. Now it might be very delicately balanced, and a slight push will cause it to roll down the hill, right? And something just rolled down the... So these Kuiper disk objects, these cometary objects, are in a quasi-stable orbit. Well, it turns out on the inner part of the zone, they can be affected and influenced gravitationally by conjunctions of the two outer planets, Uranus and Neptune. So if you can picture this, now the zone of comets is slowly rotating about the sun in the same direction as the planets, right? Now you've got Neptune coming, and then if Uranus is on the opposite side of the sun, their effects pretty much cancel out. But let's say that Uranus every, many decades separates the orbit where they actually go conjunct. Well, as Uranus is coming up, what happens is Neptune's gravity field and Uranus's gravity field can combine. Now here's a comet mass out here, and it's slowly rotating, and now here's this combined gravity field sort of tugging at the comet in the opposite, just like if you were running, you had a big rubber band on you, and the more the rubber band is stretching, the greater the tension, the slower you're going to go. It's going to slow you down, isn't it? If the two are conjuncting ahead of an object, it's going to do just the opposite. That gravity is going to pull it and speed it up. Now, if it slows down, well, first of all, if it speeds up, it wants to go to a higher orbital shell. It moves out, farther away from the sun. If it slows down, it can move closer to the sun because now it's lost energy. It comes closer to the sun and it passes within the orbit of Neptune. So now what happens is it's circulating in the orbit of Neptune, and here comes Saturn. Saturn conjuncts Uranus, but now what's happened is it's probably not a single comet that's been transferred into a sub-Neptunian orbit. It's probably hundreds of them, right? But now here comes Saturn conjuncting Uranus, and it has the same effect. And what it'll then do is transfer comets to the inside of the orbit of Uranus. And now you've got Saturn and the big guy, Jupiter. Same thing. Well, as it turns out, the transfer of comets from the inner zone of the Kuiper disk to the inner solar system is entirely dependent upon the masses and spacing of the four great outer planets. Take away Neptune, no comets delivered to the inner solar system, except very rarely and very sporadically. So again, what I'm getting at here is that when you begin to look at the design of the solar system, it's almost as if everything's carefully worked out. Well, we got to get those comets into the inner solar system where they can disintegrate and fertilize the earth with the precursors of organic life. And so we have to have a mechanism from getting from them out here to the inner solar system. The irony, though, is that those same comets that might be almost certainly now, I'm thinking, are responsible ultimately for creating conditions conducive to the emergence of biological life on Earth can also become agents of destruction. So there's kind of this cosmic duality worked into the thing. So what needs to happen then is life on Earth can first get seeded by the introduction of comets into the inner solar system, where they begin to undergo a hierarchy of disintegrations, ultimately falling into the sun or turning into streams of cosmic dust, or spawning off multiple subnuclei that can then slam into planets, just like we saw happen in July of 1994 when Shoemaker Levy 9 encountered Jupiter, and we witnessed that week, second week of July 1994, we saw 21 objects that had been a single cometary nucleus slam into Jupiter, each one with enough energy to destroy civilization on Earth many times over. And we witnessed that. And as I'm looking at that, I'm thinking the universe is giving us a very profound and important teaching moment here. It's showing us something. It's teaching us, just like the 1908 event in Siberia, the Tunguska event, taught us something very, very important about the precariousness of our situation on Earth, right? So, one of the things I think we're seeing here is that there is a system of cosmic geometry. It governs not only the measure of time, and not only of space, but of time as well. And somehow, by some means, ancient peoples all over the world saw this, understood it, and were able to incorporate it towards the great work. Now, what was the great work? The great work is represented right here behind me with these two pillars. Right? Now, if we look at that pillar up there, you see that's a globe of the Earth. If we look up here, that's a globe with stars on it. So we have terrestrial globe, celestial globe. Whenever a new Mason comes into the craft, they're brought in and they're first greeted symbolically between these two pillars, because these two pillars are setting out, here's what the great Masonic work is about. And it's what we see reflected over and over and over again in the attempts to create ancient civilizations. And we'll look at some examples here in a minute. But the idea here is the linking of earth and heaven. And the idea there is ultimately, we are the ones that can affect the future of this planet. It's like we go back and we learned back in 1980 that at the late Cretaceous, 80% of all species on Earth were wiped out in a great impact event. We learned that in the Eocene and the Oligocene, 35 million years ago, there was a tremendous destructive loss of life, now associated with two impacts, one in Siberia, one that sits at the bottom, left a big scar at the bottom of Chesapeake Bay. We know that there was an event at the Permian Triassic when 90 to 95% of all life on Earth was eliminated in some horrific catastrophic event, right? That we have the Triassic Jurassic, we have the late Ordovician, the late Devonian, and then we have, even in our own times that we humans have been on Earth, we have the late Pleistocene mass extinction associated with a climate catastrophe called what? Younger Dryas. Which is gratifying to me because 10 years ago, nobody in this room would have known the term Younger Dryas. And largely thanks to people like Graham Hancock and my own humble way of getting this out there, people now know that roughly 12,900 years ago, there was a tremendous global catastrophe. It eliminated half the great mammalian megafaunal species on Earth. Over 100 species of great, tremendous, obviously very impressive creatures didn't survive the changes, the global changes during this period of tremendous concentrated upheaval that we call the Younger Dryas. Right here in Tennessee, you know, there was at least two species of proboscidean living abundant here. What are proboscideans? What is, like, for example, I've noticed the older I get, the larger my proboscis gets. So a proboscidean is an elephant. So here in Tennessee, we had mammoths and we had mastodons. Total in North America, there were 4 different species of elephants. Who thinks about that? You think elephants, you think Africa, first of all, Serengeti Plain, etc. You might think India. But who thinks North America had more elephants than Africa does? That's pretty bizarre when you think about it. But then you think about all the other species. The dire wolves, the North American Pleistocene lion that was almost the size of a horse. The 4 species of sloths, some of them as big as elephants, right? In northern, like in the Yukon area, Alaska, you had the imperial mammoth that stood 16 feet tall at the shoulder, right? In Europe, you had the giant cave bear. You had Ursus spalaeus, the cave bear. You had Arctodus simus, the giant short-faced bear that stood on his shoulder up to 6 feet high and weighed up to 1,500 pounds. These were some pretty formidable beasts. And within a geological eye blink, they were gone. All over the world. All over the world. Now, what's the usual explanation for what happened to them? What was that?
We hunted them to death.
Yes, as we like to joke on my podcast, it was small bands of Paleo-Indian hunters with their loincloths and Birkenstocks that hunted these animals to extinction. What's interesting is that I recently did some research to see what is the latest estimate for the late Pleistocene population of the Earth. And it ranged between 5 and 10 million people. That's not very many. And then I did research, what was the estimate for the number of mammoths in the world? And it was 10 to 12 million. So I'm thinking if you've got, let's take the difference of 5 and 10 million people. If you've got 7 million people, say, how many of those that's total. That's men, women, children, elderly. How many of those are actually hunters? Now, what kind of effort would it take to slaughter every mammoth in the world? But also the great Irish elk, the dire wolves, the American cheetah, and over 100 species. And I actually saw a study once where a Russian paleontologist was attempting to calculate how much they were eating in order to eat all these animals to extinction. The number was something ridiculous. But anyways, we have this event that happens, right? What to me was interesting was because when they first dated it, I had become aware of it in the 80s, I think, because I was always intrigued by that mass extinction event and never did buy into the Paleo-Indian hunter theory. But in the 1980s, there were studies done, and they began to look at the census and begin to hone in on the date. Now, there's a spread, but there's a peak within that shows up very close to 12,900 years ago, right? Now, half of a precessional cycle is 12,960 years. You might have seen that number up in Ed's presentation. So twice that was the great year, so-called 25,920. I think it was 1996, I gave 5 lectures at Warren Wilson College. And at that point, I was talking about the mass extinction of the megafauna. And based upon looking at all of the agencies in nature that I thought were capable of taking out that many megafauna on a global scale, I couldn't come up with anything other than cosmic impact. I looked at volcanism and I thought, okay, volcanism could possibly do it, but not so quick and not so severe, and it wouldn't have been all over the world. So I came up with an impact scenario, and then I began to look at that, begin to think, I think it was probably more than one impact. And then this was just in the wake of Shoemaker-Levy 9. So I'm thinking, I think maybe it was an event similar to Shoemaker-Levy 9. There was a breakup of a great comet, and the Earth encountered the byproducts of that disintegration. And I presented this evidence, we have it recorded, and based upon looking at traditional numbers, I had concluded that it happened within a century of 12,960 years ago. I also predicted that the great floods that occurred, that I've been so, like Bradley Young, who's in here somewhere, I believe, and Ed's been with us on 3 or 4 of these trips documenting these unbelievably gigantic floods that have swept over huge regions of the Earth's surface, that the existing or prevailing explanations for those just didn't make any sense. Just like the human hunter explanation for the mass extinction didn't make sense. The explanation for the source of these floods didn't make sense. And in fact, I had read some papers in the 70s talking about the energy paradox. And this is what the energy paradox was. It was that in the old days, 50 years ago, 75 years ago, before the advent of radiocarbon dating, based upon studies of modern rates of glacial recession that was witnessed during the end of the Little Ice Age, when the swollen glaciers of the Little Ice Age, which by the way were the most extensive glaciers had been since the end of the Big Ice Age, 10, 11,000 years ago, by looking at those rates, extrapolating backwards, the assumption was 50,000 years or more for all the great ice sheets covering the planet during the late glacial maximum, as it's called, to disappear. Then radiocarbon dating came along, and it totally messed up the models because they're finding things like, well, wait a minute, there are trees growing in Canada where the ice was supposed to be 35,000 years ago, so obviously there was no ice there. That's just an example of how it came about. I mean, there was many ways through proxy studies that it became apparent, studies of sea level rise, right? Well, wait a second, there are studies showing that sea levels were almost at modern levels, that at the same time there were forests growing in Canada. What's the conclusion? Well, the glaciers were either gone or very much diminished in size. So what happened is the span of time to get rid of the glaciers went from this to this. And that's what led to the energy paradox, because in order to melt that ice, you got to have energy. You got to have heat energy. So the question was, where did all the heat come from? And so what they started looking at was what would be the places on Earth today we have the greatest amount of heat energy. And there was two places, like Sub-Saharan Africa and tropical oceans. The numbers came up roughly the same in both instances. If you were able to take this gigantic ice complex that covered half of North America, up to 1.5 miles thick over Canada, and move it to a tropical ocean, it would still take 10 times as long to melt that ice as that it actually took. That was the energy paradox. And so this was 1973. They didn't resolve it, so they had another conference in 1975, published another series of papers, didn't resolve it there either, because the only thing that had changed was the span of time actually contracted a little further with more refining of radiocarbon dates. So they said there must be an error in the data somewhere. They put it on the shelf, and that's where it sat until this day. I was aware of that work, so I thought, well, it's got to be only really what could be one of two things. It's solar related, or it's impact related, or some combination of both. My thinking now is that it was a combination of both, because we've learned since we've now deployed solar observing satellites that there is a whole family of comets that was unknown called Kreutz sun grazers, and there's a huge number of them, and they fall into the sun at an extremely high velocity. And other comets that come in to the solar system also end up falling into the sun. And it seems that there is a correlation between the infall of cometary mass and the stability of the solar corona. In other words, there seems to be a connection between the infall of cometary mass, for example, and coronal mass ejections. Now, if you had a really large comet or several comets coming into the solar system, they usually get caught in this cosmic ping pong game between the sun and Jupiter. They begin to disintegrate. The solar system, inner solar system, becomes littered with the byproducts of this disintegrating phenomena. The Earth can encounter that, which it does. Mars can, the Moon, Mercury, Venus, all of the inner planets will encounter that stuff, usually on a periodic basis. And I think that's what we're seeing when we begin to looking at the periodicity of the great terrestrial catastrophes, is that this stuff falls into the sun and there's a solar response. And then if the sun is throwing out tremendous blobs of plasma at high energy, and we happen to get caught in the pathway of this, it could be pretty serious. And it's likely this is happening. Robert Schoch thinks that's the explanation. Interesting, the controversy between Robert Schoch and Graham Hancock. Graham Hancock's in the impact camp. Robert Schoch's in the solar camp. I'm in both camps. So I think that there was probably a combination of over a couple of thousand years at the end of the last ice age, a series of events, not just one single event. Interestingly, all the critics attacking the idea of a terminal ice age catastrophe attack this very ridiculously oversimplified model. And I don't think they're looking at the full complexity. But let me circle back to a point here. We now recognize the reality of great catastrophes in Earth history. We know that since we have been here, we modern humans, I think the latest skeletal dating of modern humans, we're pushing 200,000 years old. How much earlier than that? I don't know. But in 200,000 years, there have been a whole series of tremendous global upheavals that our ancestors somehow were able to survive. Although we know that there have been perhaps 10 or 12 different species of hominins that we have cohabitated the earth with in the last 200,000 years that haven't survived. Neanderthals, what happened to them? Well, either they were destroyed in a catastrophe or maybe they were absorbed into Homo sapiens sapiens. And it's turning out that some of us actually have Neanderthal genes. So maybe that's what happened, but we don't know. But there's no fully Neanderthal hominids in the earth today that we know of, right? So it's kind of come down to us. We seem to be the species that terrestrial nature has evolved to perhaps stop this cycle of catastrophe that has not only set back the forward momentum of life itself, but as we're now finding out more and more, has set back the forward evolution of civilization. And I think that the model we have to recognize now is just as species. We could look at over 99% of all known species in the fossil record have disappeared. What we have today is just only a fraction of 1% of all the known species throughout the history of the earth, right? So what happened to those species? Well, the old models was that they were just incrementally, slowly dying away because they were evolving into other species. The model now is different. Those species disappeared because there were mass mortality events triggered by these tremendous cosmic forces, right? Now we extrapolate from that to the rise of human civilization on Earth. And I think we have to understand the model of rise and fall of human civilization the same way we do the rise and fall of species. That there are catastrophes that wipe out species and cause mass extinction events, and there are catastrophes that have repeatedly reset the clock of human civilization. And luckily, they haven't been great enough to cause extinction of the human species, so we've been able to gather our effects and rebuild after thousands of years, rebuild a new civilization. And I think each time we create a new culture, a new civilization arises, part of that motive that's encoded right into our genes is we have to get to a point where we are no longer vulnerable to the thing that has been wiping out life on this planet for, 600 million years. So that puts a heavy responsibility on us. Because like as it's been said, at the late Cretaceous, the dinosaurs were not able to do anything except sit there and passively succumb. Maybe we are nature's necessity for learning how to finally protect this planet. And maybe that's part of the large game plan, the cosmic game plan. And that if we don't rise to the challenge, we'll disappear and nature will have to evolve a new species that can do what we're supposed to be doing. So this brings us back to the idea of where we are at as a species and where our thinking needs to evolve And by contrast, where is it? Where is our thinking? What are we being taught in school is important to we, the human species on planet Earth? Well, to me, it's like a joke. It's like a very bad joke, because the consequences of this dumbing down could be profound beyond anything we've even begun to imagine yet. And now we're kind of in this situation where we are going to contrive artificial reasons to go to war with other powers on Earth that we should actually be allying with. And we've entered a dangerous era in the last couple of years. And it's not something we can shout out any longer. We have to reckon with the fact that we now have the ability to destroy not only civilization, but most of life on Earth. And from my perspective now, looking back, I know that, and even though I had plenty of criticisms of the leaders of this country and stuff going back to the Second World War when we first entered the atomic era, how we avoided apocalypse up to this point was very simple, by talking to each other. Roosevelt sat down. As evil as Stalin was, Roosevelt sat down and talked to Stalin. So did Truman. We have every president. Truman, Eisenhower, Kennedy, Johnson, Nixon met with Brezhnev at least 6 or 7 times, said we have to sit here and talk so that even though we got different philosophies of life, different economic philosophies, we're all in this boat together in the sense that we don't want to unleash Armageddon on this planet. This is the first time we've had, in my lifetime, a presidential administration that refuses to sit down and talk. What are we to make of that? Well, there's some pretty severe implications to what's going on right now, and we need to reckon with that. And, not to go, oh, well, in my day and this and that, but, in my day, my peers were getting blown to pieces and being shipped back in body bags from Vietnam. And I have photographs of being out at the largest mass arrest in American history, Washington, D.C., May of 1971, where 1 million people descended on Washington and said, you're going to stop this war. You're going to stop this war. And it was the American people that rose up and put a stop to that war, right? Now, I'm looking, what is the equivalent generation doing now? Worrying about what pronouns? Really? Wait a minute, well, this can't be real. It cannot be real, is it? Well, I think this is all part of the plan. You dumb the young people down, because the young people are the ones that are most invested in the future and are the ones who, if they're really paying attention to what's going on, they will be the ones out there saying, no, you're not going to steal our future from us. So I think it's part of this, call it conspiratorial if you will, but I think it's part of this idea that we keep people distracted as much as possible. Because there's an imperial enterprise that's the result of a zero-sum thinking. That there's only finite resources and we're going to ultimately have to fight, and who's going to control those resources. I have it on pretty good word from people that know, from geophysicists and so forth, that there's a huge oil reservoir under eastern Ukraine. Could there be any connection there with the attempts to control what's happening in Ukraine and to deny that resource to Russia? I'm not saying there is, but it certainly could be considered, right? But as we sit here right now, I've spent 7 years questioning and skeptical about the potential of alternate types of energy. Now, having spent those 7 years and having taken a deep dive into it along with my good friend Brad, are you here, Brad? There he is, Bradley. Bradley and I and our other friend, Mike Robertson, the CEO of HowTube, we spent many, many hours with a mad scientist. I call him mad because he's in a kind of a complimentary way, because most genius scientists are mad to some extent, right? Well, there is right now potentially a whole new energy source based on plasma that could completely change the whole face of the world, launch a new industrial revolution. And there are efforts to suppress that. Some of you know that I went on a Joe Rogan a few months ago, and it's never seen the light of day. Part of that reason is because of the controversies in which this whole scenario has been embroiled. But there are things happening right now that could completely change the equation within the next few months. And we'll talk about that some, but I think we should have a little bit of break, then I'll set up the slides, and then we'll come back for another hour, and we'll get into some of this stuff.